Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today we have a customer requested topic, and I always love those. And today's is a very practical one. Here it is. Analog field calibration. Well, many machines include processes that need to be monitored using analog signals. Of course, we're talking about temperatures and pressures and those sorts of things. Well, how do you know that the values that you're measuring are accurate? Well, all Horner equipment is calibrated at the factory, and of course, that should ensure years of accurate results and accurate operation. But what if you'd like to validate that accuracy periodically and maybe even recalibrate in the field? What kind of procedures should you go through for that? That's what we're going to cover today in a very practical manner. All right, without further ado, let's break down today's topic. We're going to start out by talking about what we mean by field calibration. And then we're going to dive into the different methods we can use for field calibration. We're going to start with a system menu method we can use for the micro OCS. And then we're going to talk about a logic routine method that we can use for any OCS. And we'll have plenty of demonstrations as we go. All right, let's get started. All right, so what do we mean by analog field calibration? Basically, it's the procedure we're going to use that we're going to execute periodically in the field, maybe once a year, maybe every few years, whatever the desired interval may be. But it's a procedure we're going to use periodically to ensure the accuracy of the analog systems of the machine. And today we're going to discuss multiple approaches. The first is, as I've already mentioned, using a built-in system menu function that's available in the micro OCS. Now, it's only available in the micro OCS units that have a built-in display, not available in the micro CPUs. The other methods we're going to use involve creating logic routines. And these aren't difficult or complex logic routines, but they're logic routines that will allow us to calibrate either just the analog input circuitry in the field, of the Horner OCS, or you could even use the same logic to calibrate the entire signal chain for your machine. Now, what do we mean by a signal chain or an analog signal chain? Well, when we're talking about calibrating analog inputs, really what we're talking about is just calibrating the analog input circuitry of the Horner OCS. And that's, of course, the type of calibration that we perform in the factory. But if we want to take a look at the entire analog signal chain, then we're talking about including all the components that are involved in process measurement, from the pressure transducer, if it's pressure that we're monitoring, to any kind of converter or transmitter that, the signal may be passing through. And then, of course, ultimately to the analog input on the PLC or the Horner OCS. So when we're talking about the entire signal chain, all these components are included. And today we're going to talk about calibration that includes only the Horner OCS analog input. And we're going to be talking about calibration that includes the entire signal chain. So that's an important distinction to understand. All right, now if you're going to do field calibration, you're going to need the proper instruments because, rest assured, we're using high quality instruments at Horner, and other PLC manufacturers are as well, to do the factory calibration of all of our equipment. So if you want to improve upon that in the field, you're going to need similarly high quality equipment to use for that procedure. Okay, so now if you're just going to be calibrating the analog inputs themselves, then what you need is a precision analog signal source. Okay, that's the instrument you're going to need. I'm showing an example on the screen here. That's one that we use at our factory. It's one that I'm going to be demonstrating today, but there are several of them out there from different manufacturers. Now, if you're going to be calibrating the entire signal chain, then you're going to need a little different instrument. So for instance, if you're going to be calibrating a pressure measurement signal chain, then you're going to need a precision process instrument that can measure pressure. So you can see exactly what the measured pressure is on the machine, and then you can validate that what you're getting in the PLC or the Horner OCS is a reflection of that specific pressure, and you can make adjustments from there. So those are the types of instruments you need if you're going to perform this properly. All right, now let's start with the analog calibration procedure you could use if you're using micro OCS units in the field. The X4, the X7, the X10. Okay, so this is a procedure that involves only calibrating the analog input circuitry itself, not the entire signal chain, but it's built right into the micro OCS. And in this case, of course, since you're calibrating the analog inputs, you're going to need a high quality signal source. All right, let's dive in and demonstrate now this method of calibrating micro OCS analog inputs. Let's demonstrate the field calibration procedure that's built into the micro OCS family. Now, this capability is not available in all Horner products, just the micro OCS, and we're demonstrating it on a micro OCS X7. As I've mentioned before, the key to this, one of the keys to this, is you must have an appropriate instrument. So this is a high quality signal generator, obviously a portable unit, so perfectly applicable for machine builders. But it has to be, again, a quality source that can provide a trusted value for you to calibrate your equipment with. And as you can tell from this sticker, we regularly send this unit in for validation of its outputs, okay, so that we can maintain traceability and have confidence in the calibration that we do at Horner with this instrument. Okay, so that's the first step, have the proper instrument. All right, let's go to the field calibration menu, which is accessible from the system menu. So we press the upper right-hand corner and then go to the system menu by pressing the system button. All right, you can see prominently displayed here is I/O status and calibration. Okay, and calibrate analog is selected by default. All right, it's going to give us a warning, tell us that the device is going into idle mode. So we want to accept that if we do want to continue. All right, so in the upper right-hand corner, it's telling us the channel that's currently selected, the mode that we're going to be calibrating there, along with the current value in milliamps, okay? And it's telling us if it's been calibrated or not, okay? But we're going to go ahead and recalibrate this. All right, so I would like to calibrate this in 4 to 20 milliamp mode. So what I'm going to do is I'm going to navigate to the mode, press enter, and select 4 to 20 milliamp mode. As you may have noticed there, RTD is another option, PT100 is another option. Okay, and then down here, this is where it gives us the instructions of what to do next. So let's go ahead and apply 4 milliamps, which is telling us to the signal. And basically, we're going to wait for that signal to stabilize, okay? And then when it's basically stable, we're going to press the accept button. Now, we're not looking for perfect stability here. We're going to get a certain amount of jumping around. All right, next it's telling us to apply 18 milliamps, so we'll do that next. All right, again, wait for it to stabilize around the value. Press the accept button. Okay, and then the last step is to press the save button. Okay, save new calibration. Okay, got it. All right, very good. Now, we have some other options. There is a default button here, which would allow us to change back to the kind of default factory type calibration levels. That's an option here. And then, of course, we can also go through and calibrate other channels. So I could select channel 2 input, channel 3 input, etc. Even the output channels can be calibrated. Okay, so all this is available from this calibration menu. So this is one method you could use to field calibrate the micro OCS's analog. All right, so the final step here, I want to make sure, I think I've already pressed save, but let's press it again just to be sure. All right. Okay, yeah, we did that step before the long beep, so you don't need to press it twice like I just did. But the final thing is, let's press close, and you'll notice we're back in run mode now. We'll escape and head back to the main application. Now let's take a look at the method where we use a logic routine to perform our field calibration. And this logic routine is not complex. It only involves a few rungs. It also involves creating a screen that a technician can use to kind of walk through the process of doing the field calibration. And it can be used in any OCS, whether that's a micro OCS, you don't have to use the built-in calibration procedure in the system menu, or any other OCS for that matter. Okay. Now the key to the logic routine, and we're going to cover this after we go through the demonstration, but the key to the logic routine is the scale block. So if we want to perform a 2-point calibration, where we set the machine to the minimum process value and the maximum process value, that would be considered a 2-point calibration, and we would need a single scaling block for that. But if we're going to perform a 3-point calibration, which has some advantages of some extra accuracy, then we'll have a low point, a high point, and then somewhere in between. It could be midway. It could be somewhere around a key process value that we want the machine to maintain on a regular basis. So a 3-point calibration is something you can use to even increase the accuracy more. And then the demonstration we have and the sample program we have is truly using a 3-point calibration. So that'll be nice. So now in terms of the instruments that we need, again, we can use this approach either to calibrate just the analog input circuitry on the Horner OCS, or better yet, to calibrate the entire system. And of course, if we're calibrating the entire system, then we have to have that precision instrument that's going to measure the process value in engineering units accurately. Okay, let's go ahead and take a look at our demonstration where we're going to calibrate the entire signal chain using this method of a logic routine. Now let's take a look at a calibration procedure we can use to calibrate the entire system on an analog input, not just the analog input itself on the Horner OCS, but also including the analog transducer or the sensor or the transmitter, whatever that instrument is that's in the signal path, or every instrument that's in the signal path will be calibrated with this procedure. Okay, so let's go to this screen that I've built. There's logic behind it as well, which we'll review in a minute. So what we have here is a screen that allows us to set some calibration points in engineering units. In this example, PSI. Okay, and we could set that, that's just a text field. We could set that to any 4 characters that we want, up to 4 characters. I've set it to 3 for PSI. Okay, and we can set 3 calibration points in our engineering units that we're going to calibrate the machine to. And again, we're calibrating the entire signal path, not just the analog input. And then the instrument we need for this is we need an instrument that's going to measure accurately, that we can trust, again, a traceable instrument, that in this case, that's going to measure PSI. So what we're going to do is we're going to set the machine to these 3 different PSI levels, verify it with this third-party instrument, and then once we're happy that we're at those levels, then we're going to go ahead and perform the calibration. Now, the detailed instructions are also available with this help button here. Okay, but I'm going to walk you through it, so we aren't going to, study those in detail here. So let me start by going to kind of setting the machine to that minimum pressure level, which in our case is going to be 0. Okay, and it's already there. So let's take a look and watch it stabilizing. That's what we're looking for, is for it to basically stabilize. Now again, it's never going to be perfectly stable, but it seems to be hovering around the reading that we want. Once we have that, we're going to hit the set low button, because basically we're setting the low value for this particular scaled value. All right, now I'm going to go ahead, we could do these in any order, but I'm going to go ahead and go to the high pressure. I'm going to set the machine to the high pressure level now. And I'll wait for the machine to get there and to stabilize. I'll have my third-party instrument to verify that I'm at this, 48 PSI level with my third-party instrument. Once I'm happy the machine is there, then I'm going to wait for these counts to stabilize. Once that's happened, I'm going to, in this case, set the high level, because that's where we're at now. And then finally, I'm going to go to this mid-level. All right. And so I'm going to set the machine to go to mid-pressure. And then I'm going to verify that with my third-party instrument. Okay, and again, if my instrument was displaying 11.9, for instance, I could go in and change this number to 11.9 and then set the value as well. Okay, that's another thing I could do, another approach I could take. All right, so now once I'm stabilized, which it looks like I'm about there, then I'm going to go ahead and set the mid value. All right, and now basically we've calibrated the entire system, not just the Horner analog input, but also including everything in the signal path including any transmitters or transducers that are there as well. And again, the requirement is we've got to have a trusted instrument we can use to validate, basically the PSI in this example is at a known value. Let's take a look at the logic behind the demonstration I just made here on the bench. Okay, so we've got, probably a total of 7 or so rungs of logic behind the scenes. It's all pretty straightforward. We start with a variable that is mapped to the analog input channel that we're going to be calibrating. Again, we're calibrating the entire signal path, but we're doing it through the analog input channel here. So in my case, %AI1 is mapped to this variable in the program variable window. All right, we've created a couple of real values from this integer coming in from the analog. And then the real key to this logic and to the ongoing scaling that we have that gives us the calibration are these two scale blocks. So what's happening here is if the value we're reading in from our analog sensor is between the low level and the mid level that we've set in our calibration, then we're going to use this scaling block to do the linearization. Now, if it's between the mid-level and the high level, then we're going to use this scaling block with its constants and the variables that are basically acting as the calibration constants. We would use this particular scaling block. Okay, so that gives us a 3-point calibration. All right, low, medium, and high gives us 2 scaling blocks for scaling. Between low and mid, we use this one. Between mid and high, we use this one. And then these rungs just come into play while we're calibrating. These are those 3 buttons you saw me press for setting the low, mid, and the high calibration constants. So when these buttons are pressed, we store away the current values coming in as basically as our calibration constants that are used inside these scaling blocks. All right, so that's really all there is to it. And then on the screen side of things, again, these are the 3 different levels that we're calibrating to, low, mid, and high. These are those 3 buttons that you saw for storing away the constants. This is where we monitor the values coming in and wait for them to stabilize. And this is where we see our results in engineering units. And of course, this is our editable data field that is just there for convenience purposes, so we can set the engineering units that our machine is using. In my example, of course, it was PSI. Okay, so that does it for today's material. Again, you still got a little bit of time to sign up for training in the 4th quarter. If there's any slots available, go to our website and get signed up today. Still lots of trade shows going on these days. The 3rd quarter and 4th quarter are just packed with them all over the Midwest and all over the South. Check out our schedule, come out and see us, talk to us about your application. All right, lots of ways to interact with Horner online on our website at hornerautomation.com, on our YouTube channel where we have hundreds of videos, and you can always interact with us on LinkedIn where you can find out the latest news from Horner. Okay, next week, we're going to be covering kind of a fun topic. We're going to be talking about adding a Garmin GPS to your control system. Now, we've talked about adding GPS before to a Horner control system using a great component from Banner Engineering. Today, we're going to show you an alternative to that using a Garmin unit. And that should be a very interesting topic, and we look forward to sharing it with you next week. If you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week when we talk Garmin GPS, let's get out there and do some good.